Here's a cool problem. If 3 to the x power is equal to 13, what's the value of 3 to the 2x plus 1 power? It's a good idea to start looking at this equation first, just because we have an equation, which means we could potentially solve for x. But once you go ahead and take a look at it, and you take a look at the first few powers of 3, you notice that x is going to be somewhere in between 2 and 3, just because 3 squared is 9 and 3 cubed is 27. Then if you knew how to input this into a calculator, maybe with using some logarithms, that would be one way to go about this. So we know x is between 2 and 3, but it doesn't really help us solve this right now. But let's go ahead and see if we can go ahead and solve this problem without using logarithms. So let's focus our attention on this expression here where we have 3 to the quantity of 2x plus 1 power. When you take a look at this expression, notice how in the exponent we have a sum here. So you want to try to remember some of your properties of exponents, where if you have some base a raised to the m power multiplied by the same base raised to the n power, you could just say that's going to be a raised to the sum of those exponents. That means that if we have a sum of exponents over here, we could go ahead and rewrite this expression as 3 raised to the 2x power multiplied by 3 to the first power. So if we're trying to find out the value of this expression right over here, maybe by breaking it up into these two smaller pieces of 3 to the 2x power times 3, that'll be a little bit easier for us. So again, keep in mind that we can also simplify this a little bit by saying this is 3 to the 2x power and just multiplying this by 3 or tripling it. So this 3 is easy to deal with over here. We're just going to multiply something by 3, but it's really this 3 to the 2x power that's a little bit tricky. Maybe if we take a look at this equation on the left side, we can go ahead and use this information to figure out what the value of that is. So let's go ahead and get rid of this because it wasn't really helpful. And let's look at this equation. The 13 over here is kind of random, but this 3 to the x power over here kind of is close to being similar to this 3 to the 2x power. Now, how could we get those to be the same? Well, I'm thinking what we could do here is, let's go ahead and take the left side of this. Let's take this power and let's go ahead and raise it to the second power. But when we do that on the left side, let's just make sure we do it to the right side as well. Now, one property that you've hopefully learned with exponents is when you raise a power to a power, like you have this 3 to the x power raised to the second power up here, we can actually just multiply those exponents together. This is called the power of a power property, where if you have a power like a to the m power, and you go ahead and raise that to the n power, you can go ahead and simplify that and write it a different way and say it's the same thing as a to the m times n power. And so we could just go ahead and take this left side of this expression and rewrite this as 3 to the 2x power. Now on the right side here we have 13 squared, which is just 13 times 13, and that's going to equal 169. Oh, so wait, this is kind of cool. Are you noticing what I'm noticing? This 3 to the 2x power matches this 3 to the 2x power to the right. Now if we know that 3 to the 2x power is equal to 169, we can go ahead and make a substitution and swap this out. We can go ahead and say that this would be equal to this 169 that we just came up with. So let's go ahead and say this is going to be 169 multiplied by 3. Now if you go ahead and multiply 169 by 3, we should end up with 507. And so trying to be creative and think outside the box and use some of these properties of powers, we went ahead and found out that this value of this expression over here is equal to 507. Hopefully this video made sense to you, and thanks for watching.